All right. And as I've mentioned before, if you have any questions, please just type them into the chat or raise your hand. Or if you're on your cell phone and you can't do either of those things, then just go ahead and unmute and I'll address your question. But I'm just going to continue on with what we've been doing. And right now we're working through the metric type questions. Hold on, my screen froze, or my thing here's froze for so we're just going through the metric questions. So I'm going to continue doing some of the practice questions. We did grams to milligrams, milligrams to grams, and now I'm going to do milligrams to micrograms and micrograms to milligrams, assuming this opens up. Okay. Okay, so we're working on metric to metric conversions, and then we're also doing some weight-based conversions. So we'll do those here. I already worked through the grams to milligrams, milligrams to grams. So now I'm going to show you milligrams to micrograms, micrograms to milligrams, liters to milliliters, milliliters to liters. Even if you've got this 100% and it's not a problem for you, and you don't need any help with this, it's sometimes just good to revisit these more kind of structured, straightforward problems, and then you can kind of see how I do later problems, basically following a similar format. So remember, you need to know your conversions. They won't be given to you. You need to know how to go from milligrams to micrograms. But the good thing is it's we're going to use the same value that we use to go from grams to milligrams, in that it's 1,000. Now the trick is where does the 1,000 go? So if you recall, when I set these up, I always start off with what I'm trying to get rid of, milligrams, and what I'm trying to convert it to, micrograms. And the next question is, do I know that conversion? And the answer to that is yes. I know that 1 milligram is equal to 1,000 micrograms. And then if you need to see that again, remember it was up here, 1 milligram, 1,000 micrograms. Okay, so remember, you need to have those memorized. You need to know what those are. All right, so 1 milligram, 1,000 micrograms. Notice that I don't even have to guess where things are going to go. I just said 1 milligram, 1,000 micrograms. And also, doesn't it make sense if there's 35 milligrams and each milligram is 1,000 micrograms, then that's where you're going to get your answer of 35 times 1,000, which is 35,000 micrograms. Okay. So 35,000 micrograms is the answer. Now, we're going to go ahead and convert micrograms to milligrams. So if I have 250 micrograms, and then again, what am I asking myself? Is there a way to convert micrograms to milligrams? And I know that there is, because we just did it up here. All I'm doing is switching where these things go. Right? So we know that the 1,000 goes with the micrograms, the 1 goes with the milligrams. And again, if you ever get stuck, even if you hate dimensional analysis, this is a good strategy to kind of follow, because it usually helps you to get unstuck. Okay. So now I'm going to take 250 and I'm going to divide it by 1,000. And this is where I'm going to get 0.25 milligrams. Okay. So 250 divided by 1,000 is 0.25. That's my answer. I don't round that to 0.3. I wouldn't round that to 0.3 anyways. But let's say it was 0.275. That would be your answer. You do not round simple metric conversions. And you'll see some examples of that when we get into more like a practice test scenario in the coming weeks here. All right, let's do liters to milliliters. I'm going to take my 1.75 liters. And I wanted to see if I can convert liters to milliliters. So I'm going to go back up. If you don't already have it memorized, you know that 1 liter is 1,000 milliliters. You'll notice that 1,000 seems to be the number of concern. So when in doubt, when you're doing metric to metric conversions, think milliliters, okay? Or think thousand, I'm sorry. Don't always think milliliters, obviously. So, as said before, 1 liter, 1,000 milliliters. We know we're getting rid of liters, and we get 1,750 milliliters. Now, sometimes I'll add the comma, sometimes not. I don't think that your instructors are big sticklers on whether or not you use the comma, but if you do, great. If not, don't worry about it too much. Okay, now I have 275 milliliters, and I want to convert that to liters. So can I go from milliliters to liters? Yes. Same way I can go from liters to milliliters. I'm just going to inverse the numbers. 1 goes with the L, 1,000 goes with the ML. So now we're going to take 275 milliliters divided by 1,000. And what I'm going to get is 0.275 liters. That is your answer. Okay. You do not round that to 0.28. If you do, you'll get it wrong on the test. Okay. So it is important to know there is some nuance with rounding. Just don't kill the messenger. I'm just telling you, like, there's just some things that you're like, oh, come on, is that really the problem here? It's like, is that why I missed this? Because I rounded when I wasn't supposed to. They're going to get you very psyched up about rounding everything, that you're going to start rounding things when you don't need to, but you never do rounding when you're just doing metric to metric conversions. And a lot of times your rounding is going to be saved for, like I demonstrated in the first, I almost said first episode, the first review I did, in that there was rounding when you were going between units. So when I went from metric to household or household to metric, then you might need to do some rounding. All right. So speaking of that, we're going to have some scenarios here. We might have to do some rounding because we're going from pounds, which is a household measurement, to kilograms, which is the metric unit. And this is something you'll do more in second, third, and fourth semester. And then third semester, definitely when you're doing your pediatric unit, you are going to need to know how to convert pounds to kilograms. And you're going to need to know when to round when you're doing those things. So like when you're just doing just a standard conversion, if need be, round to the nearest tenth. If you're doing a problem later on, you probably want to save your rounding to the very end. So saying all that, as a reminder, 1 kilogram is equal to 2.2 pounds. Okay. The short way I always think about this is when I go from pounds to kilograms, I'm dividing by 2.2. And in the event you're going from kilograms to pounds, you would multiply by 2.2. But I'm going to tell you right now, that very rarely happens. You very rarely are going to convert kilograms to pounds. You typically are going to convert pounds to kilograms, which is why I always usually just show it to you in one direction. So let's do these 3 problems. I'm going to set these up exactly the same way each time. And I'm still going to follow, even though I gave you a shortcut, I'm going to follow the dimensional analysis method just because it's a good safety net. If you ever get stuck and you don't know what to do, try and set up a conversion factor. Okay. So what did we say? 1 kilogram, 2.2 pounds. We're going to get rid of pounds. I know that my pounds looks like a 16, so I got rid of those. So I'm going to take my calculator, because that I don't have memorized. And I'm going to take 128 divided by 2.2. And I'm going to get 58.1818181818 repeating. So I'm going to write that out. And I'm just going to write 58.1818, just so you know that it's a repeating number. So it just keeps going. That's also a good indication that you need to round. And what I'm going to do is I'm going to round to the nearest tenth. Okay. So what that means is I'm going to look at the 8 or I'm going to look at in the hundredths place, and I'm going to decide, do I need to round up or do I need to leave it alone? Okay. So if it's 5 or greater, so 5, 6, 7, 8, 9, you're going to round up. So my answer for this question will be 58.2 kilograms. Don't write 58.18 because it'll get marked wrong. Don't write 58.1. It'll get marked wrong. Don't write 58. It'll get marked wrong. Okay. Now, in a real life clinical setting, you might be basing everything off of like, oh, it's 58. So we're going to set the, things to either 58 kilograms or 60 kilograms for whatever you're doing. That might be true. But when we're doing like the math stuff, they just want to make sure you know how to round and things like that. I always say I'm not the one making the rules, guys. All right. Then the next thing is I'm going to follow the same path. 207 kilogram pound. 1 kilogram, 2.2 pounds. And I'm going to plug that into my calculator. So I'm not going to write out the long form anymore. I'm just going to tell you what it comes out in my calculator. So 207 divided by 2.2 gives me 94.090909. So I'm just going to write out the rounded answer. Well, here, I'll just do this. I'll say 94.09, and then that we're going to round that to 94.1 kilogram. And you could argue like, well, is that 0.1 even significant? Probably not. Okay. It is a little bit more in pediatric dosages, but usually it's because pediatrics were concerned about, little kids like 50 pounds and under, right? But once you're over the 100-pound mark, a lot of things like you're talking about decimal differences when you're doing weight-based calculations. But then again, that might be dependent on the medication in question. And then one of the things, if you haven't learned already in pharmacology, is that it's not always just weight, it's also metabolism. And so kids metabolize a lot quicker than adults do. And then that's where a lot of the, where you have to be very, very careful about like overdosing or misdosing, especially pediatrics, even if they are like bigger kids and seem like they can handle it. All right. Now, in some situations, you won't need to do any kind of rounding. And I believe that this is this situation. So I'm going to follow the same strategy. 1 kilogram, 2.2 pounds. We're getting rid of pounds. 110 divided by 2.2 gives me an even, so no rounding required, an even 50 kilograms. So now you've seen scenarios where their rounding has been used and you've seen scenarios where you don't need rounding. And then also what goes without saying, like if you have an answer of like 50.2 and that's your answer and it stops at 50.2, then that's your answer. You don't need to worry about, do I round it or anything like that. You round up if you need to round up, you leave it where it is. If it doesn't need to round up, like if you got 94.12, it would just be 94.1. Okay. All right. Let's work on some intake output calculations. So just give me a second because I got to pull up the scenario that we use. So I have it. If I did. All right. So give me just a second. I'm going to make some edits here. I'm going to leave this one alone. So the fluid replacement question that we usually work with at Allegheny campus looks like this, where you have it's going to be like calculating the fluid replacement volume after the patient is voided. At some of the other campuses, like especially at like Boyce, they will take like a grouping of foods that are given to the patient, and then they're going to calculate what that total volume is. So you have to do some converting, like quarts and cups and pints to milliliters, and then you just add it all together. I'm just going to focus on what you guys need to know, because as far as I know, you're not going to do what the other campuses do in that regard. You're just going to do this fluid replacement volume question. Now, I will say I'm not a big fan of starting off with this one because it is a little bit more of a challenging question, but I think we can get through it. It'll be helpful for us. So just give me a minute, because this is your first word problem that you're running into. So I'm going to give you 2 scenarios to practice, and we're going to kind of see how this goes together. So, okay. All right. So, and then I'm going to change what this is. So let's just say, so for every, replace with, let's make this. Okay. So the, so dissecting this question, there's a couple of things. So first of all, let me read this. It says for every 400 milliliters of urine output. So for every estimated 400 milliliters patient voiding, you're going to replace that with 750 milliliters of water via PEG tube. I don't know if that's too much or too little, but I'm just making up numbers. Okay. If the urine output for the last 3 hours is 600 milliliters, what would the fluid replacement volume be? So I'm using big numbers. I don't know if that's, like I said, an appropriate thing or not. So we have 3 things relative to urine. We have an expected urine output. We have a replacement volume. Okay. And then we have an actual urine output. Okay. So expected. Then we have replacement, and then we have the actual urine output. Now, over the last few semesters, I kind of deviated from. I know you're going to find this shocking, especially since I've been talking the last couple reviews about the importance of dimensional analysis. I'm going to kind of skirt away from that, and the only reason being is because everything, if you pay attention, everything's in milliliters. Okay, milliliters. Everything's in milliliters. So it's like, well, which milliliters are we working with? Okay, so I'm going to show you how to kind of classify this, because the way this question is asked, it's going to look either just like this, or they might say, you know, the doctor orders a replacement volume of 750 milliliters of water via PEG tubing every 3 hours for every 400 milliliters of urine output. So they might just rewrite that question. Or if the patient's urine output was over the last 3 hours, and the timing doesn't really matter, it's just that's when you're probably checking it, is 600 milliliters. The doctor says to replace it with 750 milliliters for every 400 milliliters of output. What would you do? So that's really the only thing that's going to change is maybe the way it's presented. But this is the wording I pulled from one of your dosage calc books. I think it was either the Giangrasso or the Plimpton book. I can't remember which one, but or both. I mean, they have similar questions. So, but those questions come from a book source, so it's not like I just made that up. But like I said, the important parts of this is knowing, like I said, the expected output, the replacement volume, and the actual output. Okay. So I'm going to show you how I came about with the formula I'm going to show you in just a moment, and then why this works. So you learned a long time ago, even if you don't remember, you did learn it, how to do what's called ratio proportion. Okay. Which basically means, let's say I take my my replacement volume over my like expected output, and I set that equal to what I'm looking for over my actual output. Okay. So that's kind of what this looks like. Now, some students like to do this because then you remember, oh, okay, this is where I cross multiply and I get my answer. And then that is correct. Okay. And then this works. So if you're looking at this and you're like, I can vibe with this, great. Then you're doing this purposefully. And I would say just keep your replacement volume up top. It really doesn't matter where it is because you're going to solve for the unknown or solve for X. Notice I didn't put an X there because I know nursing students don't really care for algebra too much. But if you're okay with it, that's fine. The other thing that I did is I just kind of simplified this, and I said, take the actual output, whatever that happens to be, over the expected output, and then multiply it by the replacement volume. And that will give you your answer for this question all the time as well. So what that looks like is, what is my actual output? 600 milliliters. What is my expected output? 400 milliliters. And then what's my replacement volume? 750 milliliters. So then you just put this into your calculator. I always say, like, if you're not comfortable with some of these, like when I write it this way, just remember, just multiply across the top. So 600 times 750, hit equals, and then divide by 400. And you're going to get a replacement volume of 1,125 milliliters. And I know that sounds like a real big number, but if you think about it, how long does it take someone to consume a liter of water? You know, depending on how thirsty you are, you might be able to consume a liter of water in 10 minutes or even 30 seconds, depending on how thirsty you are, like I said. But that liter of water, it doesn't take long. And then it says every 3 hours. So, and then they might be on like a pump or something like that. I don't know how this all works out, but I just wanted to use bigger numbers. You might see smaller numbers. It's not a big deal. Now, the one thing you don't want to do is say, oh, okay, I'm going to take the big number out over the little number out times the replacement volume. And the reason being is I can easily say that their fluid replacement volume was less than the expected output. You would still give them a replacement volume. It would just be less. And I'm actually going to do that in the next problem. So let me do that real quick. So when I come down here, I'm actually going to change this number. So I'm actually going to make this, I'm going to make this 600, and I'm going to make this 400. Okay. So that number is actually going to be less than the expected output. So if I follow the same formula that I created, now remember, I created this formula based off of what's called ratio proportion. That's just the strategy that I chose to use for this. And the reason I'm using that instead of dimensional analysis is because of all the MLs. There's no way to like eliminate MLs unless you subcategorize them as ML out and ML in. That's why I used actual out over expected out, because I'm hoping that makes sense when you guys come back and look at this. So what is my actual output in this scenario? It's 400 milliliters. Okay. If I don't put a number, if I don't put something there, it's gonna give me problems after I write. So my actual output is 400 milliliters. What's my theoretical? 600. So you see how the number on the bottom is bigger than the number on the top, which is different than what we saw in the previous problem. But all I'm doing is the actual over the expected. Okay. Then I'm going to multiply by my replacement volume, which is 500. Now, let me ask you something. You don't need to answer this. It's rhetorical. But if you're sitting there looking at this, if I need 400 milliliters to replace, or 600 milliliters to replace with 500, but it's only 400, then we're not going to give them more than 500. That's a way to kind of rationalize and think about this, think this through before you put your final answer down. You'd be like, oh yeah, if it's less than 600, then it's going to, the replacement volume is also going to be less than 500, but we'll still have a replacement volume. So let's see what that is. 400 times 500 gives me 200,000. And then I'm going to divide by 600. And I'm going to get 33 or 333.333333 repeating. And so I'm just going to round that up. And I'm going to say 333.3 milliliters. Okay. Now, I have a feeling that when you actually get this question on your test, it won't have like a big, like weird decimal at the end. It'll probably just be a very solid, finite answer. At least that's what I've seen on previous tests. So that would be my expectation moving forward. But that's what this will look like. So, all right. So as I said, I'm going to keep these short and sweet, but I will be back on doing the next section tomorrow afternoon, Thursday at 2:30. And then I will email once I have posted this review, if there's any changes that are happening to any of these reviews, you will know. I will email the class. That way you have an idea. And as always, if you have questions and you feel like something's not being addressed, or you have a question on how you're answering a question, just email me. Just reply to the emails I'm sending you via Blackboard and let me know what your question is. So I will see or talk to you guys either tomorrow or next week.
Thank you.
You're welcome.
Thanks, Dr. Rad.
You're welcome.
Thank you. Thanks.
Yeah, you're welcome.